So let's go through this post order once again. We have to start this over. It only does 15 minutes at a time. So post order means left child, right child, parent. Pre-order was parent, left child, right child. In order was left child, parent, right child. Post order was left child, right child, parent. So these orders are really when do you count the parent. So post order is last, right? So you go down and you say A, H, E. Then you skip this parent and go down and do the left, M, Y, T, and then you can do this parent, J. So an expression tree is when you take math expressions and put them in a tree. And that way you can have this precedence built into the tree. So this is the root. It's 8 minus 5. So if you go in order, 8 minus 5. But pre-order means you do the parent first. So it's minus 8, 5. That's why they did this. And the post order is left, right, parent. So it's 8, 5, minus. And you might say, well, hold it, don't we always do it with this in order stuff? Well, what's interesting is if you do it in the post order, then it'll keep things nice. Or I think you probably do it in pre-order, but it's post order is what they use usually. Each left node contains a single operand. Each non-left node contains a single binary operator. The left and right trees of an operator represent sub-expressions and must be evaluated before applying the operator. So it's really left, right, parent. So you go left, left, right. So it's 4, 2 plus. And this is then the left, right is 3 times. So if you go in order, 4 plus 2 times 3. But post order is sort of interesting. It's reverse Polish. It's 4, 2 plus. So it gives you the two numbers and then says what to do with it. 4, 2, add them. Then that answer, which is 6. 3, multiply them. 6 times 3 is 18. So this, we'd have to have parentheses if we do this in order, because it would do the, well, maybe. It would depend. But the parentheses are necessary to look at. That's the infix, which we just saw. What about the infix is what we're used to seeing. The prefix is when we do the parent first, left, right. And then we're done with the left and do the right. That's why it goes times plus 4, 2, 3. But this is the one, reverse Polish is what I got used to. It's 4, 2 plus, then 3 times. So you get 6, 3, and multiply the 6 to 3. Interesting. When a binary expression tree is used to represent an expression, the levels indicate their precedence. Operations of higher levels are evaluated later. The operation at the root is always the last operation performed. So, evaluate this. So we say, if you want to go in order, it's 8 minus 5 times 4 plus 2 divided by 3. 8 minus 5 is 3 times 4 plus 2 is 6. 6 divided by 3 is 2. So 3 times 2 should be 6. See if we did it right. I think so. You notice we need a bunch of parentheses to make sure that first one's right. That postfix is the nicest one, because you're going left to right, I guess. 8,5 minus, and then 4,2 plus, and then you do the 3 divide. So the 4,2 plus 3 divide is done first, and then that times when you're all done. Interesting. So you have to put parentheses in when you do the in order, when you hit this level. And then the right, and then divide in between. The pre-order doesn't take any, but you're sort of working backwards, right to left. Post-order, you still work left to right, and you may not be used to it. But notice it does the left side, then the right side, and then the middle. The root. This was supported by National Science Foundation under this grant.